Hi, this is Mr. Singh here, and today we're going to be looking at lenses, which is part of the AQA separate physics syllabus. Before we start on lenses, have a look at these 6 retrieval practice questions. You can pause the video here. Okay, let's see how you got on. So, number 1, name the 2 types of waves that you need to know about: longitudinal wave and transverse wave. 2, what's the difference between the 2 waves? Longitudinal waves are like a spring where they carry the energy that is parallel to the flow, to the movement of the waves. And a transverse wave is where energy is perpendicular to the flow of the wave. Number 3, what do waves carry? Energy. 4, what type of wave is light? It's a transverse wave. And number 5, what is the speed of light? It's 300 million meters per second. And number 6, why can you see lightning before you can hear it? Because light travels faster than sound. Sound travels at 330 meters per second. If we move on. So you can see there are 3 objectives today. We're going to look at how images are formed during lenses. We're going to look at constructing ray diagrams, and we're going to try and calculate the magnification. And you can see the keywords: lenses, convex, concave, magnification, image, virtual, and real. So let's move on. Lenses. Lenses are used to refract, that means bend, light to form an image. And we need to talk about convex lenses and concave lenses. So a convex lens is also known as a converging lens. It brings together, and they're given this symbol. It's a line with the arrows pointing outwards. And we're now going to look at trying to construct a ray diagram. So you have a line, an imaginary line going through the lens called the principal axis. You have a point called a principal focus in front of the lens, and same distance behind the lens, principal focus, sometimes called focal points. Focal length is the distance to the center of the lens. Here is what will happen to the rays as they enter a convex lens. You can see they all meet at the principal focus. So if we have a convex lens and we know the principal focus, the examiner will probably tell you where the object will be, how many centimeters away. So the object is there. You can see it's beyond F. It's upright. You need to draw a line going from the top of the object to the lens and through the principal focus on the other side. You then need to draw a second line, again from the top of the object through the center of the lens, and you can see where the 2 lines meet. Where the 2 lines meet, that is where the image is. You can see the image is upside down. It's bigger than the object, so it's magnified. And we say it is real. Upside down, inverted, magnified larger, and we say it's real. And that's the case if the object is beyond F. Now we can have 2F. If the object is beyond 2F, let's have a look at the image. So we follow the same rules. There you go. And then a second line from the top of the object through the lens, and you can see where the 2 lines meet. And this time, you can see the image is there. The image is still real. It's still upside down, but this time it's smaller, so it's diminished. If the object is now between the lens and the F, let's have a look. What is the image? So again, follow the same rule. Second line. You can see the 2 lines do not meet now. Okay, so if we trace them back, they will do that. So there's your image. Now the image is virtual. We call it virtual. It appears to come from a different place. It's now upright, same way, and it's bigger than the object, so it's magnified. And this is a magnifying glass, really. That's what a magnifying glass does. If we look at concave lenses, these are also known as diverging lenses, and they're given the symbol that. You can see that straight line, but this time the arrows are pointed inwards. There's your principal axis again. There's your principal focus. Same distance on the other side. Focal length. But let's have a look at what happens to these rays now. They spread out. They don't meet at the principal focus. But if we trace them back, you can see where they do meet. So if we draw a ray diagram for a concave lens, let's have a look at this. There's the object, beyond F. Follow the same rule. There's your second line. Obviously, the ray will spread. And you can see where the image is. The image is virtual, it's upright, but it's diminished, it's smaller than the object. But it's virtual. If we then have the object beyond 2F, let's follow this again. There you go. And you can now see the image is virtual, still upright, and it's still diminished. If we have the object beyond the lens and the F, there you go. And the image is virtual, upright, and diminished. Magnifying glass, what I did mention before, they use convex lenses. They create a virtual image that is upright, and you saw the ray diagram before. And the object must be closer to the lens than the focal length. And that was the diagram you saw. And that is the diagram of a magnifying glass. You can see the object is between the lens, between the lens and the F. To calculate magnification, it's the height of the image divided by the height of the object. That will give you the magnification. Here's a couple of questions that you can attempt. First one is calculate the magnification, and the second one is a typical AQA question where you will have to draw this to scale, and the best thing to do here is use a graph paper. You can pause the video here, hopefully you've got a graph paper and you can have a go at this. Okay, what we are going to do now is, you'll see an example of number 2 in one of the AQA questions. So we're now going to look at AQA questions. Here is a ray diagram. You can see the object. It's a concave lens. So the question is, which point on the graph above marks the position of the principal focus on the lens? And then which 2 words describe the image? And the first one's done for you. So I'll go back. Okay, so which point on the graph marks the position of the principal focus? It's B. And which 2 words describe the image? Well, the first one's done for you, and it's upright. There's your 2 marks. Next one, calculate the magnification. Use that equation. You can see the height of the object, the height of the image. You will need a ruler here. And there it is, magnification is 0.4. D, complete the sentence. As the object is moved further away from the lens, the size of the image will decrease. Here's another question. A light bulb is placed between a convex lens and the principal focus of this lens. At position N, shown in figure 1, the light bulb is then moved to position M, a larger distance from the lens. Describe how the nature of the image formed changes as the light bulb is moved from position N to M. You can pause the video here. And here we go. So it's worth 3 marks. The image would decrease in size. The image would change to real. And the image would change to inverted. Worth 3 marks. Here's another question. You will need a graph paper here. An object O is very near the convex lens. So it's between the lens and F. It's a convex lens. Complete the figure 2 to show how the rays. Here we go then. So you can pause the video here. Here we go. So a ray through the centre of the lens, a ray parallel to the principal axis, passing through the principal focus on the right of the lens, and the image drawn where rays cross, worth 3 marks. And that's what you should have got. Here's another one. The object distance is the distance from an object to the lens. The image distance is the distance from the lens to the image. Figure 3 shows how the image distance changes with the object distance for 2 identically shaped convex lenses, A and B. Each lens is made from a different type of glass. Question. When the object distance is 4 centimeters, the image distance for lens A is longer than lens B. State why. 1 mark. Okay, so let's have a look. Because lens A has a greater refractive index, except lens A is more powerful, except lens A has a shorter focal length. Here's another one. When the object is moved from lens B and the principal focus, the image size changes, and the table shows the magnification produced by lens B for different object distances. And you can see that 2 columns, object distance in centimeters and magnification. Use information from figure 3 and the table. Describe the relationship between the image distance and the magnification produced by the lens B. Once you've done that, so when the magnification increases by 1, the image distance increases by 10. Except 1 mark, it's a linear pattern, or as the image distance increases, the magnification increases. Do not accept directly proportional. Here's another question. A third convex lens, lens C, is made from the same type of glass as lens B, but has a shorter focal length than lens B. Lens B is shown in figure 4. Complete figure 4 to show how lens C is different from lens B. 1 mark. Diagram B showing the surface of a convex lens C having greater curvature than lens B. And that will get you the 1 mark, greater curvature. And that concludes our lesson today on lenses.